Okay, Year 12, in this video we'll be covering exercise 3B, which is on arithmetic series. So to start with, you need to know this. A series is a sum of terms. So a sequence is just all the terms, and a series is when you add all of them together. And you'll come across these quite a lot in different places in A level. So for example, now when we're doing arithmetic series, later on we'll look at binomial series. And for those of you doing further maths, you might look at things like Taylor series and so on. So it's just summing the terms in a sequence. Now, before we go any further, quick question, pause and have a think here. If I asked you to add up all the numbers from 1 to 100 as quickly as you possibly could, what would you do? Right. So I don't know, you may have thoughts, you may not have any thoughts, doesn't matter too much, but I'm just going to tell you a quick story. So this here is Gauss, who's quite a famous mathematician, and there is a story which is probably fictitious, but it's still quite a nice story, so I'll tell you it. Which is that when he was 8 years old and at school, he was already like very good at maths, and he could do everything much quicker than his teachers and so on. And so one day his teacher went to him, "Fine, have a go at this then." And about 2 seconds later, Gauss had worked out the answer. And the way he did it was like this, is he thought, well, if all the numbers from 1 to 100, we can write them in pairs. So 1 plus 100 is 101. Then there'd be a second pair, which would be 2 plus 99, which would also be 101. And we'd go on and on and on and on and on like that until we'd added up all the pairs. So in total, there would be 50 pairs. Each of the pairs would add up to 101, which means the total of those numbers is 5,050. So I don't think 8-year-old Gauss actually did this. It's still a nice story though, and that principle is what we'll be working on today. So without further ado then, last lesson we looked at arithmetic series and using this form for the nth term. Now the sum of the first n terms can be written using this formula. It looks quite complicated, it isn't too much, but I would suggest you write that down now. In terms of proving it, for example, if we had this arithmetic sequence, 2, 5, 8, 11, 14, 17, we could write this out as 2 plus 5 plus 8 plus 11 plus 14, etc. Then we could pair that 17 shouldn't really be there. Then we could pair these, we could reverse them. So 14, 11, 8, 5, 2. All of the pairs sum to 16. So 16, 16, 16, 16, 16. Then there's 5 lots of 16, which is 80. Okay, and so therefore, like the sum of the first 5 terms is 40. So more generally, and you don't need to know this, but it has been an exam question before, and it's also quite like a nice university interview question. Your general sequence is A plus D, A plus 2D, all the way up to A plus n minus 1D. So reversing it, A plus n minus 1D, A plus 2D, A plus D plus A. When we add those together, we get 2A plus n minus 1D, and that's 2 of the sum of our sequence, and so therefore the sum of our series, is n over 2, 2A plus n minus 1D. There is an alternative formula. You do really need to know the first one. The first one's like more versatile, but this is like another way of saying the same thing, which is this: S of n equals n over 2 brackets A plus L, where L is the last term. So if you know what the last term is, this is quite a useful formula. If you don't know what the last term is, you should use the formula on the previous slide. So without further ado then, let's have a go at these 3 questions here. So we want to sum the first 30 terms of the following arithmetic sequences. So to start with, let's just identify what A is. A here is 2, D here is 3, and N is 30. So then S of 30 equals 30 over 2 brackets 2 times 2 plus 30 minus 1 times 3, like that. And then I'm going to input that into my calculator. So it's which gives this 1,380. and 65. Similarly here, the one in the middle, I would always recommend we begin. A is 100, D is -2, N is also 30. So then S of 30 is 30 over 2, 2 times 100 plus 30 minus 1 times -2. And then I input that into my calculator. Giving 3,870. Final type, again, just begin by writing out what your A, D and N are. So A will be P. Our common difference here will also be P. We're adding on P each time. And N is 30. So then S of 30 equals, I should have done that. Let me restart this again. S of 30 equals 30 over 2. Then 2A, which is just 2P, plus 30 minus 1 lots of D. Therefore, we get 15 lots of 2P plus, P there, plus 29P, which gives 15 lots of 31P. Using my calculator now to evaluate that, gives 465P. And then final question for now. Find the minimum number of terms for the sum of this sequence here to exceed 2000. So to start with, A is going to be 4, D is going to be 5, and N is what we're trying to work out. Now S of N here is going to be 2000. And then in terms of everything else, we get N over 2 brackets 2A. 2A here would be 8 plus N minus 1 lots of 5, like that. And because we want this to be greater than 2000, we put this in. After that, we're just going to solve to calculate N. So I'd multiply both sides by 2. And then let's do some simplifying. So 4,000. I'm just going to deal with this internal bracket for the moment. So we get 5n minus 5. So 4,000. Then expanding out this bracket gives 8n plus 5n squared minus 5n, or 4,000, 3n plus 5n squared. So we get 0, 5n squared plus 3n minus 4,000. Using your calculator now to solve that quadratic. Yeah. We get either 27.985 or we get minus 28.585. So n is going to need to be a positive number, so then we're going to need to round this 27.985 up to 28. So the minimum number of terms needed would be 28 times. With that in mind, year 12, have a go at exercise 3B. Now again, feeling free to skip on to some of the harder questions if you need to.